Welcome back everyone to my teacher. I know I haven't been making videos lately because I've been really busy and occupied with other things. But I know that you are gonna have, some of you are actually gonna have your exams coming soon in October and November, and I've had a couple of requests on the YouTube comments. So I'm gonna start with this chapter called Differentiation, and we have about 8 questions today, and let's get on to it. Okay, the first question is quite straightforward. This video is going to be a bit long because I've tried to compile as many different types of differentiation questions as I can to show the diversity of the type of questions that can actually be asked for. So we shall start with some basic ones, which is quite straightforward. So this is an exponential type of function, and you are asked to find the differentiation of it. So when you differentiate this, you make sure that let me just use this simpler one. Okay. So you make sure that there are 2 terms. So you take the first term first and you repeat what's written, and then you differentiate the top. So the differentiation of the top will give you 2. Therefore, you put the 2 in front. Okay, and do the same for here. Differentiate the top. Okay, you get a -2. So I put the -2 in front and repeat back what's given. Okay, so it's as simple and as easy as that. So you get 2 marks right away. Okay, moving on. By using the substitution u equals to 2x, find the value of y when dy dx equals to 3. So they are asking you to find dy dx equals to 3 and the value of y at that period of time. But you need to use the substitution that is given. Now you must remember that when they say by using the substitution and they gave you the substitution, you must make sure that you use this. Okay, so sometimes they might say by using this or otherwise. Right, so when they say or otherwise, you can use other methods in order for you to find your answer. Okay, so you have to just be very careful with the language that they're using. In this case, let's just use a substitution. So we're going to start by doing this. 2e 2x minus 2e negative 2x equals to 3. So I just did that. Dy dx equals to 3. Then I'm just going to bring it to this side. Okay, -3 equals to 0. And the next step would be, now I'm going to think about how am I going to substitute this. Okay, so first of all, I'm going to try to make everything that has the power of negative to make it into a fraction. So it's easier for me to see the values. Oops, made a tiny error there. It should be 2 over e to the power of 2x. Now this becomes positive. Okay, now I can make my substitution quite clearly. Because e to the power of 2x, I'm just going to substitute all of it into u. So I get 2u minus 2 over u minus 3 equals to 0. Now we have a nice equation. All we need to do is make this into a quadratic by removing the fractions. So I'm going to take u, multiply by all the terms. So you get 2u squared minus 3u minus 2 equals to 0. Okay. Now all you need to do is just do a factorization and you get u minus 2, 2u plus 1 equals to 0, right? So since you have 2 possible values for u, let's try both. So u equals to 2, and here you should get u equals to -0.5. Now remember that u is actually e to the power of 2x, so e to the power of 2x equals to -0.5. Now if you take a look at it, it's quite impossible for us to get a negative number if you have an exponential, okay, that has a base that is positive, right? So no matter what number that you put here, you will never ever get a negative value. Therefore, this is an invalid solution. Don't take it. Okay, we'll just look at this one. So e to the power of 2x equals to 2. And let's just keep it like this. All right, because we are not looking for the value of x. right? So you don't have to find x and do everything else. We're just looking for the value of y when dy dx equals to 3. So what are we going to do? We're going to go back into this equation here. All right, so just let me try to put it up here. Okay. So we're going to use back this equation here. So y equals to e to the power of 2x, all right, plus 1 over e to x. I just changed it into a fraction. So notice that e to the power of 2x equals to 2. So I'm just going to substitute that. So this becomes 2. And if you simplify everything, you're going to get 2.5. And that's basically the answer. All right, hope that wasn't confusing. Let's go to the next one. Okay, so notice that most of these questions are related to each other, which means if you don't do this right, you will never get the answer for this. Okay, and you will never get the answer for this either, because they're all related. So you have to be very careful with the first part that you're actually doing. Okay, let's go on. So now this is a rate of change question. So given that x is decreasing at the rate of 0.5 units square, per second, find the corresponding rate of change of y when x is equals to 1. So they've given you a couple of things. Now the very first thing that you need to know is that what exactly am I looking for? I'm actually looking for rate of change of y, which in other words, you would write it like this. So we are looking for dy over dt. Okay, so when we are looking for this, you must know the formula for rate of change, the general formula for rate of change that we can actually make use of. So that would signify like this. So dy dx can actually be equivalent to dy over dt, which is rate of change of y, multiplied by dt over dx. All right. So this cross formula is useful, and you can replace this with any other things. Like for example, sometimes you might be looking for rate of change of area, so that you can use dA dt, for example. Okay. So notice what actually happens here is the dt will cancel off, the time will cancel off, and you will be ending up with dy and dx. Okay. So now from this equation, we know that we are looking for dy dt, which is this component, which means that we need to try and find this component and this component. Okay, so we're going to make use of all the information that we have in order for us to do that. So first things first, what is this? Rate of 0.5 unit per second. This is for x, which means we are looking at dx over dt that is given to us as negative 0.5. Okay, why I put negative? Because it's decreasing. Now, the next one is they've given us the value of x. So let's keep that as well. So we have two information here that we're going to make use of. Right, and then we're going to put it inside here. Okay, so I'm going to rearrange this so that I can have my subject as dy dt. So I will end up with dy dt is equals to dy over dx times dx over dt. So if you're not sure how you get this, all you need to do is use this equation, right? And then rearrange, make dy dt as the subject, and then you will end up with this. So note that this has changed. So it has inverted now. Okay. So the next step is basically to put back all the information that we have in order for us to solve this. All right. So I'm going to do that. So dy dx, we have already gotten the dy dx much earlier. So I'm going to use back this one. Okay. So that would end up being 2e 2x minus 2e negative 2x times negative 0.5, which is the dx dt rate. Now, where do I make use of x equals to 1? So x here has to be changed to be equivalent to 1. So we're going to make that substitution. Okay, so 2e. I'm actually doing step by step. Normally, I'll just straight away go into this step. Okay. All right, so we got that. Now, the final step is only putting all this into the calculator. Make sure you put them right, and then you should be able to get negative 7.25. Okay. So that's basically rate of change. So we're going to look at some other types of rate of change later. Right, question number 2. Differentiate the following with respect to x. So for the first part, you need to understand that this is actually a product rule. So we're going to make use of the product rule. So a product rule states that you may see it as a different way, but I tend to use this because it's a bit easy on the eyes. So u times v prime plus v times sorry, I'm having a bit of a sore throat, times u prime. All right, so what is this u and v? By now you should be able to know what u and v are, but you can actually just pick any of this to become u or v. So I'll tend to take this as u and this as v. All right, so the first step usually I do is to take out the u and equate this so that it's very clear. All right, and then I differentiate the u. Okay, I should get negative 2x in this case. All right, so v, I should be getting this one. So I just write that up clearly. And v prime, which is the differentiation, should be 3 over 3x plus 1. How do we differentiate this? We differentiate ln first, and you get 1 over 3x plus 1. And this 3 actually comes from inside. So differentiate the inside, and you should get 3 as the multiplication. So you multiply by this with the 1 over 3x plus 1, you get this. Okay. So just double check how to differentiate ln functions if you're not so sure. Okay, so we're here. The next step is basically to substitute all the things into this. So it's quite straightforward. You shouldn't be making too much mistakes here. So f prime x equals to u, which is 2 minus x squared, and then the v prime, which is 3 over 3x plus 1, plus ln of 3x plus 1, which is the v, and then u prime is negative 2x. All right, so there's no need for you to make any sort of simplification in this particular case, except that maybe because there's a plus here and there's a negative here, you can just bring this in front to make it look a bit nicer and neat. That's about it. Please do not expand this and try to complicate things for yourself. Okay, there's no need for it. Okay, so you should get something like this. That's it. So it just makes it look a bit nicer and cleaner. Okay, so the next one is basically using the rule for quotient. So this is a division of two different functions. So we're going to make use of a quotient rule. So the quotient rule says that f prime is actually equivalent to v u prime minus u v prime over v squared. Now, just one small thing to note, some common mistakes that students tend to do is this. So here you have a plus. So you can actually swap this in front and this at the back, and it doesn't change anything, okay, because it's a plus function. But in this case, you cannot do u v prime first because this is minus. You will end up changing the entire value. So just be very careful that you should start with v u prime. Okay, just continue on the steps as usual. This is u, this is v. So I'm gonna do one by one. U equals to 4 minus tangent 2x. U prime is equals to secant. Okay, differentiation of tangent is always secant squared. Therefore, negative 2 secant squared 2x. Where did I get this negative 2? I differentiated the inside here. Because there's a negative, differentiation of 2x is 2, negative 2. Okay. Again, if you don't understand the differentiation of trigonometry, please go and Google search. You should be able to find more examples. So v is the bottom, 5x, v prime is equals to 5. Right, just the next step is basically just substituting here. So f prime is actually equivalent to 5x, okay, negative 2 secant square x minus 4 minus tangent 2x 5, and at the very bottom you have 5x squared. Again, you don't need to make any form of simplification. You can just leave it like this. If you do see any obvious simplification that you can actually make, then you do it. But in this case, it's not really necessary. If you want, you can just take the 5, put it in front. That's up to you, right? Okay, 6 marks for this. This is a bit of a long-winded and tedious question, but ultimately it's not that difficult. Okay, so let's try this. Okay, so you're given that fx is equals to this, and they are asking you to find the value of x for which the second derivative is equals to 0, which means you just need to differentiate this twice and then equate that last differentiation value equals to 0. So let's do this step by step. So the very first one that I will do is I'm going to change this into a proper non-fraction, okay, into a power format, so that's easier for me to differentiate. Some of you are probably experts, so you don't need to do that. You can do it by mind. But just for me to show, it's easier to do this way. Okay, so I just changed this into a power fraction, power format. All right, now I can differentiate easily. So this should be 2x, half negative times negative, you get positive, and 324, x minus by 1, so you end up with negative 3 over 2. We are not interested in the first differentiation, so we have to go to the second derivative, which is going to give me 2 minus, this time it's going to be negative 486 x negative 5 over 2. Just be very careful with the values at the top for your power. So we're done with the basic things. So you probably already get some marks in. Okay. All right. So the next step is basically the solving part. So you need to equate this with 0 as mentioned in the question. So 2, 486 x to the power of negative 5 over 2 equals to 0. All right. So then I just move this to the other side. I'm going to get negative 486 x negative 5 over 2 equals to negative of 2. All right. So I'm just going to simplify and make this a bit faster, quicker. So when I simplify this, I'm going to get x negative 5 over 2 equals to 1 over 243. So this is basic algebra. You just need to move things to the other side. Negative becomes positive and you get this. All right. So now this is where things become a bit more confusing to people. All right. So what we need to do is to try and make this into a format that is similar to the left-hand side so that we can actually make comparison and find the value of x. So I do this. Okay. I kind of know from experience that 243 can actually be changed into something that has 5, which is 3 to the power of negative 5, right? So 3 to the power of 5 here, with the fraction, it becomes negative. Okay, now some of you again might be stuck here thinking, how do I get this 2 here? Now think of it this way, right? So in order for me to get the 2, I need to try and multiply this with something that has a square. Okay, so I'm going to do just that. I'm going to introduce something slightly different here. Okay, so notice what I'm going to do here. So I'm just going to do 3 squared, all right? But I'm going to also include this under the fraction. So when I do this, I'm actually not changing the value of this particular term. The reason being, if you notice, I can actually just cut off these 2 like this. So when I do this, you essentially get back 3 to the power of -5. Okay, so I'm just going to remove that and I simplify this further. All right, so 3 squared, I'm going to get 9. Now it's a lot clearer that this is now equals to this, right? Therefore, x must be equals to 9. You can check again in your calculator. This and this, 3 to the power of -5 should be equals to 9 to the power of -5/2 if you're not very sure. All right, so that's basically how to solve this question. All right, let's go on. Question number 4. We are almost halfway there. Let's see. So you're given this function and you're asked to find dy dx. Okay, so this is a power function. Let's just change this into an easier format for us to work with. So I'm going to change this to y equals to 4x plus 1 bracket 3. And this entire root, I'm going to put it in a bracket and power it as half. Okay, you can expand this bracket now and you end up with 4x plus 1, 3/2. Now I can start doing my differentiation. Okay, so dy dx is equals to, take the power, bring it to the front, 4x plus 1 minus the power by 1, you will end up with half. Differentiate the inside, you get 4. So the next step is just to simplify and you will get 6, 4x plus 1 power of half. It's as easy as that. I tend to try and make things, the final answer, in the same format as the original provided value of the function. So I would write it as 6 square root of 4x plus 1. So the power changed back to a square root. It's not necessary. If you're not sure how to do the conversion, just leave it like this. Okay. Hence, find the approximate increase in y as x increases from 6 to 6 plus p, where p is small. Now when they say hence, it means you have to make use of the previous answer. Okay, so we'll do that. But first, let's try and understand what's going on here. Let me just zoom in a little bit. Okay, so this is called approximate change. Okay, so in order for us to do approximate change, you need to understand the general formula. That is not to say general formula, but it's more like a general equation that is used to estimate approximate increases or decreases. So, ta-da! So you have this thing called delta y over delta x is approximately equivalent to dy over dx. Notice that I didn't put the term equals. So it's a common mistake, but sometimes it doesn't get punished. So it's okay if you want to use equals. But I'll really suggest that you use this symbol. So this symbol basically means that it's an approximate value. It's not exactly equal, but approximate. Okay. So delta y and delta x stands for small change of y and small change of x. So the small change can be any change, but it should be usually quite small. For example, it could be 0.01, 0.02, and things like that. All right. So, or it can be in the form of unknown, like in this case. So, in order for us to find the answer, first of all, we need to try and identify what are we looking at. We are trying to find y, approximate change in y. So let me make that as the subject. So delta y Okay, it's approximately equals to dy dx multiplied by delta x. So we now only need to find the conditions for dy dx and delta x. Now from the question, I know what is delta x because x is given that it's increasing from 6 to 6 plus p. So delta x is basically just the amount of increase, which is p. So we would know that p is actually a very small number. Okay, it could be anything, but we don't need to know necessarily. Okay, so the next step is basically trying to put the dy dx. We know that the original value of x was 6. It's important to note that, which is given here. Okay, this is the original value. It changed to 6 plus p with the addition of a small change, p. So now we are ready to tackle the question. So dy dx, we have found it to be 6 root 4x plus 1. Delta x was p. Now one thing missing was the x value. We take the 6 and substitute. Okay, 4, 6 plus 1 multiplied by p. Okay, put everything inside, simplify this, you get what? 6, 24, and so on. Okay, 25, square root 5, 30. Okay, and that's basically your answer. So if you notice, I just spent a lot of time explaining, but if you know what you're doing, you can actually do this within 2 minutes. 2 marks, 2 minutes or less. Okay, we're halfway there, finally. Question number 5. Now, this is a tedious question. Look at that, 7 marks. So, this is a full application question with no diagrams, and it looks like it's about maximum minimum, okay, problem. So let's do this. An open rectangular card box with a square base is to have a volume 256. Let me take note of that first. Find the dimension of the box if the area of the cardboard is as small as possible. So this is a minimum value problem. Okay, so understanding that this is an open rectangular box is extremely important. When I first tried this question before the tutorial, I actually made a mistake because I was trying to do it as fast as possible and I missed out that this is an open rectangle and I didn't get the right answer. Okay, so don't make that kind of mistake. Okay, so what do we do? First of all, you need to draw a diagram so that you can actually understand what's going on. So that is something that I would always recommend. So try and draw an open rectangular box. Okay, please don't mind my drawing. It's usually terrible, but somehow, okay, yeah, it's not too bad. All right, okay, my rectangles are not in the same size, and this doesn't look like a square anymore, but just please, okay, just imagine that the bottom here is a square. Anyway, so I will try and give them labels. So this height here is something that we do not know, so we put that as height. These are the dimensions, by the way, and these are x values. It's up to you, you can use different terms, but it's easier for me to use this. Okay, so the bottom should be a square, therefore this and this should be the same, and this is a height. Now another thing I would like to just make sure is to show that this is actually an open box, so that when I'm doing the calculations later, I don't make a mistake. Right, so now where do we even begin, right? Okay, so this is how I would do it. So step number 1 is that I know that height here is in a different term or different variable than x. So I'm going to try and make h in terms of x. To do that, we are given some information. So the first information that is given to us is this. So volume is equals to 256. So I'm going to try and make use of the dimension I just drew to get this. So I will do this. X squared, which is x times x, base area times height, should give me the volume 256. Now I can actually change h to be in the form of 256 over x squared. Now it's in terms of x. So that's great. One mission accomplished. Now what else can I do? So they mentioned another information. We are looking for area. Now when you have a three-dimensional object and they mention area, it has to be total surface area. Okay, if they don't mention, you have to make an assumption that this is a total surface area. So which is why it's important to know that this is an open rectangular box, which means you do not take into consideration the area of this top part. Okay, so you only have 1, 2, 3, 4, 5 faces. Normally, a three-dimensional square or rectangular box would have 6 faces. In our case, it's just 5. So since we are looking at area, let's try to formulate the area. Okay, so area should be equals to, of course, the base area, which is x squared, plus the rectangular faces. How many rectangular faces do we have? 1 here, 1 at the back, 2 at the side. Okay, so 4 x times h. Each rectangular face is x times h area. All right, so we do that. Now again, this h is in terms of x. Okay, so I'm going to make that change. Okay, and substitute that h. Now the reason why this is important is because we cannot differentiate this if you have 2 different variables. All right, so now it's a lot easier for me to make the differentiation. So I'm going to simplify this, and I'm going to end up with x squared plus 1024 over x. Okay, so we're almost there. So the next step is to try and get the value as small as possible. Oops, something wrong. Okay, apologies, there's something wrong with the OneNote. But anyway, so let's go on. So we want to find the smallest value. We have to differentiate and equate it to 0. So let's try and get the dA dx first. Okay, and we are going to get 2x. All right, and for this, you differentiate, you should be able to get 1024 over x squared. So once we get this, equate this to 0. Okay, why equate to 0? Because when you take the differentiation equals to 0, you can find either the minimum or maximum of a function. Okay, so 2x minus 1024 over x squared equals to 0. Okay, multiply this, okay, to get rid of a fraction. So you get 2x cubed minus 1024 equals to 0. Simplify. Okay, get this, solve for x, and end up getting x equals to 8. Okay, now the question is, we are not actually looking for x. We are looking for the final answer, which is on the dimension. So we must make sure that we get the dimension right. Okay, so one of the dimension is in h. So I'm going to get the value of h as well. So let's see. H is equals to 256 over 8 squared. So I just took this and then substitute with the x value. So now h is actually 4. So we have all the values that we need. So basically the dimension is 8 by 8 by 4. This should be your answer. All right, so you can actually put the centimeter as well, because they say it's in centimeter cube. So you can even write that this is all in cm. Okay, or 1 by 1. All right, so that's basically how we do minimum value problems. by, of course, drawing a diagram. Okay, we have 3 more questions to go. Let's go. Alright, so there's some technical issues. Let me just quickly... Okay, that was the tiny glitch, but never mind. Let's look at question number 6. So, we have y equals to blah blah blah. Okay, this is just a simple quotient rule. So let's start with u equals to x squared. Differentiate this, 2x. V equals to cos of 4x. V prime, negative 4 sine 4x. Just make sure you know how to do the differentiation of trigonometry. Cos will change to negative of sine. And the differentiate inside, you get the 4, put it in front. Okay. Then all you need to do is to substitute. Alright. So again, use the same formula where we actually use the quotient rule. Okay, or b squared. So first one is cos of 4x, and then 2x minus x squared, negative of 4 sine 4x, alright, over cos 4x and square. Okay, so that's basically it. Of course, you can actually change this to make it as a plus and so on. But I'm just a bit lazy, so I'm just going to leave it like that and then continue the next question. Okay, so the approximate change in y when x is increasing from pi over 4 to pi over 4 plus b. Okay, it's the same methodology that we used earlier. So x is given as pi over 4, okay, and approximate change in x is given as p. It changed plus p, right? So we just do that. Okay, so the only difference in this particular question is that it's in the form of pi and trigonometric functions. So you just have to be a bit more careful when you're doing the calculation with your calculator. Okay, so what do we do? As usual, I'm using this formula, delta y, delta x, which is approximately equivalent to dy dx, and rearrange to find delta y. Okay, delta x. Okay, so the dy dx, we use back what we had earlier. Okay, so this is what we had earlier, right? So what I'm going to do is that I'm going to straight away substitute my x into this x. Okay, so I'm skipping one step because I've already taught you how to do this earlier. Okay, 4 times pi over 4. This is basically x. I'm substituting pi over 4 times times 2 minus pi over 4 square minus 4 sine, wow, this is a bit confusing, 4 times pi over 4, okay, over, sorry about my straight line, cos 4 times pi over 4 bracket square. So essentially what I did was that we already had the dy dx, which is here, and I took the pi over 4 and put it into all of these x values. And therefore, you should be doing this one by one. Don't try to put everything into the calculator. It's going to give you a mess. Okay, you might get the wrong answers. So please try doing this one by one. So you will end up essentially getting negative 1, okay, pi over 2 minus 0 over negative 1 squared. Okay, and at the very end, you should get negative pi over 2 p. That's the answer, or you can also leave it in the form of radians. Do not leave the answer in terms of degree. Do not change this into a degree and try to use degrees. The reason being is if the question gives you in pi or radians, your final answer should be in that form. Okay, do not change it. If they gave this in degrees, then your answer should be in degrees. Okay, second last question, almost there. This looks like a quotient rule, but with a bit of a twist. I didn't know that I put up so many quotient rule questions. Okay, I must be tired and sleepy. Okay, anyway, so u is equals to 5x squared, u prime equals to 10x, v is equals to 1 plus x squared, v prime is equals to 2x, and then we're going to get, let's see, dy dx. I'm just going to straight away do it without writing the formula, because I've already showed that 2 times just now. Okay, 10x minus 5x squared, 2x over 1 plus x squared and squared. Okay, we're done up until here. Now, these are the type of question when you actually have to simplify the top so that you can actually make comparison to what is given. Okay, so now I will do some extra steps. So the extra step would be to try and simplify the top. So I'm going to end up getting 10x plus 10x cubed minus 10x cubed. If I were to expand the top, the bottom remained the same. The reason is because they didn't really make much changes to the bottom here. Okay, it's exactly the same, so just leave it like that. And finally, you will end up getting 10x over 1 plus x squared squared. So note that this is k, and this is k. Therefore, k is equals to 10 by comparison. Done. Okay, so the next question is a bit more different. So we haven't really done this type of question yet. Now I know why I put up that extra question that is similar to a quotient rule. But okay, find the coordinates of the stationary point on the curve and determine the nature of this stationary point. So stationary point means if let's say you have a function like this is a stationary point, this is a stationary point, also known as turning points or max and minimum. Okay, there are many ways to address the same thing. Okay, you just need to know all the terms. Okay, what do we normally do? We do a dy dx equals to 0. And we have already gotten the differentiation much earlier, right? So our differentiation earlier was 10x over 1 plus x squared squared. Let it equals to 0 and try to make x as the subject. So this entire thing will be 0. Okay, and you'll end up with x equals to 0. That's nice to have, easy to work with. Now put it back in the original function value because they're looking for a coordinate, right? Okay, and this coordinate is on this curve. So I'm going to use back this y. Okay, so y was equals to 5x squared over 1 plus x squared. Okay, so at x equals to 0, what do we get? We're going to get y is equals to substitution 0 squared 1 plus 0 squared, and we end up with the 0. So therefore the stationary point that we're looking at is 0 0. Okay, that's one answer. Now the other answer is to try and get the nature of the stationary point. Now to get the nature of a stationary point, you have to do second derivative. So you get the second derivative of this. I'm just a bit too lazy to show the full steps. So you need to get the second derivative of this, okay, and then check what are you getting. So in our case, we're going to get d squared dy x squared, dx squared equals to a positive value. Now if the second derivative is positive, therefore the nature of the stationary point 0.00 is a minimum. Alright, so all you need to do is just differentiate this one more time and then get it and then compare whether it's positive or negative, and finally show that if it is positive, therefore the point is actually a minimum. That's it. If it is negative, then of course it's a maximum. Alright, so we have one final question. This video is probably going into the late 40 minutes. I'm already having the signs of my sore throat coming back. I've been talking a bit too much and I haven't drank water yet. Okay, but never mind. Let me just complete this. Okay, so the total surface area of a solid cylinder with radius r and height is given by this. So they've given you the formula, so that's nice. And they mentioned that r is increasing at a rate of this. You'll need to find the rate of increase of a when r is equals to 6. So what are we looking for is rate of change of a. So we take dA over dt. Okay, must be equals to dA over dr times by dr over dt. So this is the same formula that I was showing much earlier. The only difference is now it's about area. So I've changed those values to reflect the question. And instead of x, I'm using r, which is the variable in our equation here. So what are we looking at? We are looking at rate of increase of a when r is equals to 6. So let's try and make sense of this. First of all, they've given you some information, which is this guy. So this guy is actually rate of change of the radius, which is dr over dt. Okay, so I'm just going to take this first. And we know that the radius value is 6, given in the question. Alright, so we have this. Now the next step is for me to do the differentiation. So let's differentiate. dA dr is actually equals to 2 pi r blah blah blah. So differentiate this. We're gonna get, let me see, 4 pi r plus 10 pi. Now just be very careful. Questions like this, please don't change the pi into 3.142 and so on. Do not do that. Keep your answer in pi until pretty much the end of the question, if possible. Okay, I'll show you why later as well. Okay, so once we have this, we just need to put it into this equation and solve the problem. Okay, so again, I'm going to write dA over dt equals to dA dr, which is this. Okay, 4 pi. I'm going to change the r into 6 plus 10 pi multiply by our rate, which is dr dt, 0.2 over pi. Simplify here, I'm going to get 34 pi times 0.2 over pi. Now, do you notice that if you maintain the pi, it will just cancel off quite easily and you'll get the exact value that you're supposed to get, which is 6.8. If you have at any point substituted this to 3.142, you're not going to get this answer. Okay, so you're going to get something slightly different. So we don't want that. We want it to be as accurate as possible, so keep it until the very end. Alright, so that's basically it for differentiation. So we've done 8 questions, and I think some of you requested for 2 other topics, which is on integration, surds and indices. Okay, so I think probably the next one I'll be doing either integration or surds of indices. So I'll try my best to upload it tomorrow. Right, thank you everyone. Please do subscribe and please do freely share this with your other peers who are actually taking up IGCSE for Add Maths. All right, bye-bye.